Hey guys, matrix operations, and what we're going to talk about is matrix multiplication. And matrix multiplication is difficult because you can get confused as you work along. So this one here can be tricky. But let's talk about it, because once we get a pattern and establish, okay, this is how we do it, then it makes it much simpler. The math of it is very simple. We're multiplying and adding, but it's kind of easy to get lost in what you're doing. So the first thing we're going to do is just talk about the basic definition of matrix multiplication. So for an m times n matrix A and an n times p matrix B, again, row column, this is also row column. This is still m times n per se. But the reason that it's color coded in different letters is because it is going to be a little different, but because it deals with matrix B. So for an m times n matrix A and an n times p matrix B, the product A times B is, and we'll call it C instead of A and B in there, is an m times p matrix. The A sub ij and the B sub ij deal with the different entries inside of that matrix. Once I do the multiplication and I end up with an m times p matrix where C sub ij is equal to A sub I1 times B sub 1j plus A sub I2 times B sub 2j. What this right here is saying is that I'm multiplying the row times the column. It's difficult to be able to see this until we get in there and we do an example. But this is the definition of what I'm going to do. And this part here is where it can kind of get confusing. But please let me point out, we're going to multiply two numbers together, and then we're going to add it to the product of two numbers. So multiply, multiply, add together. You can only multiply two matrices when the number of columns in the first matrix is equal to the number of rows in the second matrix. So the number of columns in the first matrix, A, must be equal to the number of rows in the second matrix, B. This is why we have m times n and n times p with the color code. And this is illustrated right here. In my example, I have three different matrices. Order of those matrices: 2 rows, 3 columns, 3 rows, 2 columns, 2 rows, 2 columns. I want to find the product of A times B. The first thing that I do is I write out the order of A and the order of B, and then I compare the number of columns to the number of rows. Are they equivalent? Yes, 3 and 3. What my order will turn into are the two remaining numbers. 2 times 2. That will be the order of the new matrix that I create. That's where we get this up here. See, m, p, p. The ends in the definition must be equal. Alright, with that being said, let's look at the product of AB and the math that's involved in finding it. Okay, here we go. I have color coded to help us to be able to visualize. So each row first with the first column. So this is row 1. So what I have to do is I make a mark over here, because I do get, I have slight dyslexia, and once I get a bunch of numbers going, it's easy for me to get lost in it. So I have to mark and I have to really pay attention to what I'm doing. So I'm taking each row, I'm going to do the first row with the first column. So 2 times 4, 2 times 4. And then I'm going to add that to a negative 1 times 3. I'm doing the first row in the first column on this one. So I can even mark the column. And I'll mark it lightly because I'm going to erase it. Don't highlight and don't do pins whenever you do this, because you're going to end up flipping and having to redo it again. You could do highlighters if you use like yellow and blue and green. So with that being said, so first row, first column, 2 times 4, negative 1 times 3, 1 times 3. And I'm going to add those together. So 2 times 4, 2 times 4. Negative 1 times 3, negative 1 times 3. 1 times 1, 1 times 1. That is going to be my first entry. That's going to be A or C sub 1, 1. All of that. The product, or actually the sum, but the product and sum of row 1, column 1. Next, I'm going to go to row 2. Remember, each row first times the first column, and then repeat with the next column. So I'm going to say 3 times 4, negative 2 times 3, 0 times 1. But what I do before that, because I will get confused in what I'm doing, I'm going to mark my other column. So 3 times 4 plus a negative 2 times 3 plus 0 times 1. This is going to be C sub 2, 1. All of that. Next, I finished the first column. I'm going to move to the second column. So now I'm over here with my stuff, and I'm going to start again with row 1. Row 1 times the second column. So I mark row 1. I know that's going to be 2 times a negative 3. A negative 1 times 2, and 1 times a negative 1. So 2 times a negative 3, 2 times a negative 3. Negative 1 times 2, negative 1 times 2. 1 times a negative 1, 1 times a negative 1. This is going to be C sub 1, 2. I'm still on the second column. I've already completed the first column, but now I move down to the second row. So I mark it. 3 times the negative 3, negative 2 times 2, 0 times the negative 1. Multiply, then sum. This is my new matrix. 6, negative 9, 6, negative 13. And that is matrix multiplication. Okay, so you see the math that's involved here? The math is not difficult. The only thing that's difficult is making sure you stay on task with doing the first row to the first column, the next row to the first column until you complete all your rows. So each row first with the first column, and then you move on to the next column and starting over with your rows. Go through each row you have with the next column. So I ask that you watch the publisher's videos, critically think and structure your homework, and good luck with your homework.